Good morning and welcome to day 2 of the WA Mining Virtual Conference. It's a real pleasure to be here sharing this wonderful event with all of you people that are joining us today. This is day 2. We had a very exciting day 1 just today, starting with an introduction from our sponsors. We then followed by a really great presentation from Andrew Shelton, giving us a very deep insight into the impact of coronavirus on the economy. Graham Stemway from BCI gave us a very interesting perspective on how coronavirus actually is impacting the innovation ecosystem, accelerating certain shifts and creating some pivoting required in the way technologies are evolving. That followed by an amazing presentation from Nicolas Cubera, who gave us an insight into what visualization is bringing and is doing to our operations today. Matt Schneider gave us an insight on SaaS models and how every company today has an opportunity of leveraging data to actually change their business models. That was followed by Jackie Coombs, who gave us a great presentation on all the fantastic work that Amara is doing. And then finally, we had a great presentation from CSIRO, Daniel Roberts, who gave us a real deep insight into hydrogen and how hydrogen is emerging as a choice for future green energy, and how that, as part of a green mix, can change the way that we're operating and can position Australia as a future supplier not only of hydrogen, but actually hydrogen technology. And so we start today with the second day. I'm really excited about the opportunities and what you will be seeing today. The first presentation will be by Control Systems Technology. You'll see a video presentation highlighting their capabilities and their offerings. We will follow that by a presentation from Osvaldo Ursua. Osvaldo will speak around the emerging new business models that are coming our way, how society will need to look differently at the way that we engage between shareholders and communities. That will follow by a presentation from Laura Mottola. Laura is a world-class lean expert. Laura will be speaking about the capability of typical lean culture within the mining industry, but also the intersection between lean thinking and technology, and how the both together can actually accelerate. There's nothing more amazing that can happen in an organization when you bring the innovation capability of people and you leverage it in an effective way with technology. That will lead us into our roundtables. Osvaldo will be holding one for those that are interested in having a more intimate conversation with Osvaldo, and for those that are more interested in having a conversation with Nicolas, who presented yesterday. After lunch, we will have Adrian Beer, the CEO of Mets Ignited. That should be a really interesting presentation from Adrian. Mets Ignited has done a lot of enormous work in accelerating the innovation ecosystem in Australia, and Adrian will be able to share what's coming in the next couple of years. That will follow Sue Kay, who will be presenting on automation and robotics. Sue was the author of the first automation robotic roadmap developed in Australia. She spent time working at Data61 and is now heading the Queensland hub around robotics. That should be, again, a very interesting presentation. That will follow with 2 more roundtables. One more roundtable around the skills required to deploy autonomous systems. Peter Sherwin she's just actually responsible for the developing the courses that are being developed here in WA, and she will be able to share that with you today. And then in the afternoon, we will have a presentation from Adam Seisman, the acting deputy head of the Australian Space Agency, giving us an insight into mining and space connections and the applications and opportunities for our sector. And finally, we'll close off with a presentation from Miranda Taylor, the CEO of NERA, the sister growth centre to Mets Ignited, and Miranda will be talking about the challenges and opportunities for moving towards a low carbon, sustainable and circular economy. So a full day, an interesting day, a fascinating day. I thoroughly hope that you will enjoy it. Stay with us. And now I will pass on to Ian Burrell, who will be presenting a video on the capability of control systems technology, and Ian may be available for a couple of questions straight after the video. So over to you.
Good morning and greetings to everyone attending the West Australia Mining Virtual Conference, Day 2. I'm Ian Burrell, the Managing Director of Control Systems Technology, and we specialise in the manufacture of high accuracy belt scales. Today, I'm presenting a case study of a recent installation in South America. On a recent visit to a copper mine in South America, we learned of an accounting problem at one of the many large copper mines there. The mining company had no confidence in their existing belt weighing equipment and asked if we could help. Actually, as soon as I saw their conveyor, I knew they had a problem with belt weighing. Their conveyor was very long, with high lift, and the belt tension had to be very high and variable. A real nightmare situation for an accurate belt scale. The mine personnel said that they were at their wits' end with the equipment. It was apparent that they were not getting any assistance from the supplier. We were invited to analyse the existing equipment. The conveyor is 473 metres long with a lift of 71 metres, and due to a vertical curve, the belt scale was located 253 metres from the tail at a vertical lift of 25 metres. At the belt scale location, the belt tension is 31 tonnes. This is a very difficult location for a belt scale. To illustrate the difficulty of the location, note that given the 1,000mm idler spacing, it takes 31 kilograms of weight on the conveyor to deflect the belt by 1 millimetre. Since the weigh frame only supports about 2,000 kilograms, this would represent an error of about 1.6%. The customer belief was that the belt scale had a bias or systematic error of up to 4%, and this is a long way out for a 0.25% system. So, as requested, we subjected the existing belt scale to our engineering analysis. We interpret three components of belt tension: fixed, load variable, and random, and we interact them with three components of belt scale misalignment: fixed misalignment from the installation standard, load variable misalignment from weigh frame deflection under load, and random misalignment from roll out of round. Our calculated error was 1.7%, in the order of 10 times worse than the customer's expectation. We were also requested to design the alternative equipment, which actually had to be located even further up the conveyor in a still worse location, so that the existing scale could be compared. We ended up proposing a 4-idler scale, with each idler set spaced at 4,500 millimetres, some 4.5 times longer than the standard spacing on the conveyor. This would be a highly unusual custom designed belt scale with a weigh length weight of 10 tonnes, 5 times more than the existing scale. The new unit, taking into account the weigh frame weight and the long idler spacing, is more than 20 times more stable than the existing unit. But 4,500 millimetre spacing, how is that possible? The fact is that if belt tension is very high, then idler spacing can be very wide, depending upon roller bearing size, of course. However, CST has a patented design which facilitates long idler spacing by providing very good belt support. This is our close-spaced roller rack, or CSRR, as shown. The belt has extra horizontal rolls between fully winged sets, in this case spaced at 4,500 millimetres, The CSRR combines the benefits of good belt support and long equivalent idler spacing. At the same time, wing roll loading is acceptable, and we have years of experience to show that the system works well. And this is the unit we proposed to the mining company. A relatively large belt scale with 10 tonnes of calibration mass and a wavelength of 18 metres. Definitely a sizable unit. It has to be supported on 4 load cells, each with its own little hip roof. All of the 4 full idler supports has 2 calibration masses of 1.25 tonnes each. We were able to get an order for this equipment. However, we had already been thinking about ways to improve the design. The first proposed waveframe design had very low deflection at the ends, but more deflection near the middle, and the steel sections were likely to make maintenance difficult. So we revised our design midstream and ended up providing a symmetrical pair of belt scales with very small deflection at the far ends and less deflection in the middle than with the previous design. Our system now had 8 load cells instead of 4 and could be configured either as one scale or as a dual redundant pair. So the alternative design is much more open and maintainable. It has the calibration masses applied directly to the idler sets. Each mass is split to allow a 50% linearity test. We did not linearize against static mass. We only linearity test to prove waveframe health. The design has the added advantage of offering dual redundancy, and the wade-to-wade transition between the 2 waveframes is an errorless internal force. The CSC electronic system is able to accept 8 load cells, either as 2 individual inputs or grouped as 1 belt scale. We retain the option to configure the system as 1 belt scale or a redundant pair. As you can see, on our electronics, there are 2 independent sets of terminals for the 2 waveframes, and each is also able to have its own tachometer. And this is what the front panel looks like. This is the remote display captured from my own PC in Sydney via a 3G modem from site. Each belt scale has its own display and setup data. We have complete remote control for maintenance and troubleshooting via a secure VPN tunnel and a custom PC client. So we put the order for this equipment through our Revesby, Sydney factory, where we produce both mechanicals and electronics. Here the project is seen at the first trial assembly stage, and the system is assembled again after surface finishing, which in this case was galvanizing, and then is performance tested with its own electronic set. And finally, it's time to pack the system into a 40-foot container. The equipment was delivered to a South American port, unpacked out of the container, and trucked to site, whereupon it was again assembled into modules for lifting into place. The equipment was removed from the container at the port, and we were pleasantly surprised to find that all the parts made it to site intact. This was quite an important installation for CST, and we normally provide our own installation supervision team. This is a large job and time was short, so it seemed that at least 2 of our technicians should be available at all times during the 48-hour shutdown. There was an argument for at least 4 people to cover the 24-hour operation. In this case, we provided 5 of our Australian citizen specialists, including myself. First, we all had to have 6 days of safety inductions on top of a 2-hour medical, which checked everything from blood type to intelligence. The inductions were interesting since they were conducted totally in Spanish, and we had to pass 2 tests every day. Fortunately, 2 of our team speak Spanish, and we managed to pass the tests. The inductions were necessary, otherwise we would not have been able to be within 1 metre of the conveyor, and otherwise we could not have made any manual adjustments ourselves. Then to enter site, we had to have our tools catalogued. The rule was that everything we took on site, whether an iPhone, a computer charger, mouse, screwdriver or spanner, could not be taken off-site again unless it appeared with serial number as appropriate on a signed-off list. It is actually much easier to work on Australian sites than in South American sites. The installation was conducted over 2 consecutive 48-hour shutdowns. The safety standard was extreme, even to the extent that anyone working in our own cubicle had to wear special electrically rated boots. But some aspects, such as fatigue management, were less stringently controlled. Our team are mainly concerned with the all-important alignment, and while there was considerable communication and coordination problems, we got the job done. Commissioning and calibration came at the end of the second shutdown and was relatively uneventful. The 2 halves of the system were calibrated completely independently. There is no plan to recalibrate the system in the short term, since the calibration will be stable for years. The system became operational early December 2019. We were lucky to have timed this work before the outbreak of COVID-19. Since commissioning, we've been able to remotely monitor the system via a secure VPN connection. By way of summary, these are the extra benefits which we provided to this customer beyond their initial requirement, which was simply for a 0.25% belt scale. The symmetrical dual redundant system is a form of built-in quality assurance. Since the 2 halves are not fudged to agree, they continuously demonstrate the quality of the installation and provide confidence to the customer that there is no bias error. This is a record of the agreement between the 2 halves of the system. The data was remotely gathered from the audit trail and captures the totalizer as it was reset every day. This data shows that the 2 halves of the system consistently agree in the 0.06% region. This is acceptable for a 0.25% belt scale and is a holistic record of total system health. There is some noise in the data since some days had very small deliveries, and also no provision was made for the amount in transit between the 2 wayframes. I want to repeat that the calibration of this system will remain stable for several years without adjustment. As a matter of further interest, some interesting data about belt wear can be extracted from a stable belt scale like this one. The above graph shows how the conveyor belt is becoming lighter with wear. It's losing approximately 0.5 kilograms per metre of length per month. This information is useful for predictive maintenance, and this data was captured remotely from the automatic zero tracking log. This concludes our South American adventure. The customer now has a belt scale that they can have faith in. If you have any questions, please ask them now or send me an email.
Fascinating presentation, Ian. And thank you for that. How many of those types of installations have you completed around the world?
Thank you for the question, Rick. That one is a bit unique, so there's only one exactly like that, but we have similar installations with dual redundancy in Australia, in Townsville, for instance, and we have also sold another similar system into South America recently. It's just a new thing for us, and we're always developing something new, I guess.
And so your focus is obviously Australia and Latin America. Are you expanding and getting demand from other jurisdictions as well?
Well, for us, copper is the market that we haven't done much with. Excuse me. We have done a lot in iron ore and coal, and perhaps grain and metals, but copper is the thing. So that's our focus now.
Well, with Osvaldo here, we might be able to create some introductions in Chile. So Ian, thank you very much for that presentation.